So we're going to have a look at how you use a probability tree to calculate the probability of independent events happening. Okay, so it can happen with two or more events, but the majority of the work you'll see will be regarding two different things. So if you have a look at this question, I just want you to think about what the probabilities will be and whether you think you've got any idea how you would start to fill in this probability tree. You get it pre-drawn out in your books for me, and then I will go through it with you. Okay, so if we have a look at the question, I have 7 red sweets and 5 green sweets in a bag. I randomly select a sweet and then replace it. Now this replace part is really important, and that will change dependent on the question that you've got. So this is the type we're going to have a look at for today. I then select another sweet and then replace it. So at all times, there will always be the 7 red sweets and the 5 green sweets in a bag, because we're not going to eat them, we're going to put them back each time we've picked one out. Okay, we're then asked to work out what the probability that both sweets are different colours is. Okay, we're going to worry about that second part of the question first, and we're going to make sure that we can fill in our probability tree diagram. So they're fairly similar to a frequency tree, except with a frequency tree we had the numbers at the ends of each of the branches. With a probability tree, the words are at the end. So that's the first difference. And it's not a number that goes on it, it's now a probability that goes on it, so a fraction or a decimal. Okay, we don't tend to use percentages at this point because they're much harder to deal with. So a fraction or a decimal. Ideally, if it's a fraction in the question, you use fractions throughout. If it's a decimal in the question, you use decimals throughout. In this particular question, you've just got 7 red sweets and 5 green sweets. So you think about the probability of getting a red sweet is going to be 7 out of the 12 possible sweets. Okay, so if you just remember in terms of notation, the probability of getting a red sweet, so we write it like that, is going to be 7 out of 12. And the probability of getting a green sweet is then going to be 5 out of 12. And that helps us to get started with filling in our probability tree. So every time we see a red, I'm going to put 7 out of 12. And when I see a green, I'm going to put 5 out of 12. Now this first set of branches is talking about the first sweet that I'm going to pick out of the bag. Then I put it back in. So I've still got the 12 sweets in the bag, and then I'm going to pick out a second sweet. So if I picked out a red one first, the probability of picking out a red one again is still 7 out of 12. And if I pick out a red one first, the probability of getting a green is still 5/12. Or we can go back to the start. If I pick out a green first, then the probability of getting a red would still be 7 out of 12. Or if I picked a green first, the probability of picking a green again is 5/12. Now, what you'll notice at the top here that I've put in red are a times and an add. And this actually comes from the and the or rule that you've looked at previously. So when we've got the probability of something and something happening, we multiply those two events. And when we've got the probability of something or something else happening, we add those things together. So whenever you deal with a probability tree, remember you are always multiplying along the branches, and then you add up the probabilities at the end. So we've completed our probability tree by filling in the probabilities, but we actually want to work out the probability of each event happening. So the probability of getting a red and then another red is 7/12 multiplied by 7/12. Now you can use a calculator for this, but ideally you want to actually refresh your memory on how you multiply fractions. If you keep everything with the same denominator, it's much easier to check things at the end. So remember, when you multiply fractions, you multiply the two numerators together. So 7 times 7 gives me 49. And we multiply the two denominators together. So 12 times 12 is 144. Then our next potential probability would be a probability of getting a red and then a green. So my notation is R and then G. So that's going to be 7/12 multiplied by 5/12. So 7 times 5 gives me 35, and I know 12 times 12 is 144. Then the probability for my next set of branches with this time would be a green and then a red. So green and then red. And therefore it's going to be 5/12 multiplied by 7/12, which just by chance comes out the same as the one above, so 35 over 144. And my last branch would be then where I have a green and a green. So the probability of a green and a green is then 5/12 multiplied by 5/12, giving me 25 over 144. Now what we should do at this point is add all of these things up. So 49 over 144 added to 35 over 144, added to 35 over 144, added to the 25 over 144, and that should all add up, and this is where your calculator will help, in giving us 144 over 44, which is 1. Okay, and we know probability always adds up to 1, so the chances are highly likely that we've got this correct. We can then have a go at answering the question. So what's the probability that both sweets are different colours? And this is where all this notation comes in handy. So here, these two were both the same colour. These two were different colours, so I'm interested in this one. These two are different colours, so I'm interested in this one. And these two are the same colour. So I'm actually interested in these two parts from my probability tree. And the symbol over here tells me if I want to know, I could have the probability of a red and a green, or the probability of a green and a red. So that's where the OR rule comes in, where you add those two probabilities together. So therefore, the probability of different colours is then equal to the probability of getting a red and a green added to the probability of getting a green and a red. And therefore we can use the values that we calculated. So 35 over 144 added to 35 over 144. That will then give me 70 over 144. And therefore we just need to simplify that as much as possible to give us 35 over 72. Okay, and that's how you fill in a probability tree. I'm going to show you another one now, this time where we're just using decimals. So just bear with me a second. Right, so if we have a look at this one, I would again like you to get this written out so that you can fill it in as we go through it in a minute. So have a go, fill in as much as you can, and then hit play when you're ready for me to go through it with you. Right, so on this one, James goes to an arcade. He has got one go on the teddy grabber and one go on the penny drop. The probability that he wins on the teddy grabber is 0.2, and the probability that he wins on the penny drop is 0.3. And we're asked to complete the tree diagram. So with every probability tree question, the two branches will always add up to make 1. So the probability of winning on the teddy grabber is 0.2. Therefore, the probability of losing will be 0.8 because they add to make 1. And this set of branches is all about the teddy grabber. Then this set of branches is about the penny drop. So we know the penny drop probability of winning is 0.3, and the probability of losing then, because it adds up to make 1, is 0.7. And then those probabilities will be repeated down the bottom as well. So 0.3 for win on the penny drop and 0.7 for losing on the penny drop. We can then use that to work out all of our probabilities, but remember, we want to write our big times sign up here and our big add sign over here to remind us that's how we calculate those probabilities. And these are all in decimals, so we want to carry on using decimals. So the probability of a win on the teddy grabber and a win on the penny drop will be 0.2 multiplied by 0.3, and be careful with your decimals. That will then multiply to give us 0.06. Then my next one will be the probability of win and then lose. So that one's going to be 0.2 multiplied by 0.7, giving me an answer of 0.14. Then I've got the probability of losing on the teddy grabber and winning on the penny drop. So 0.8 multiplied by 0.3, that will give me 0.24. And then my last one, so losing on both of them, so the probability of a lose and then a lose is going to be 0.8 multiplied by 0.7, giving me 0.56. 0.06. And remember, at this point, you want to check 0.06, add 0.14, add 0.24, add 0.56, do in fact all add up to make 1. And then we can have a look at answering part B. So part B, work out the probability that James wins on the teddy grabber and he also wins on the penny drop. So again, if we look at the things we've written out here, which is why we need to do this notation all the way through, it's really important. It helps you answer the questions. We're looking for a win and a win. So that is just this one. We've already done all the working out. And so the probability of winning on the first one and winning on the second one is 0.06. Okay, have a go at the questions. Please make sure you're asking if you're not sure and mark your work as you go through, and let me know if you need any help or extra work to do.